So let's now cover the interfaces part of lab 10 and 11. The first class here is about a person, and actually there is nothing new in it except the local date class, the use of dates. And for the use of dates, I have covered dates in a separate short tutorial, not only date, but also time, and local date and time, local time also. You can refer to that tutorial. Let me go now to the example of interfaces. As you see here, we have an interface called payable. And there is only one method in the interface, which is get payment amount, and it should return double. Interface payable, one method. Below the interface, you see invoice and employee. And look at the arrow. It's a dotted line. It's not a straight line, like hourly employee or salary employee. When it is a dotted line, it means implements. And this is used with interfaces. Now, what an interface is? An interface is very similar to the abstract classes. However, usually all the methods of the interface are abstract. Interfaces are used in situations where the classes do not really have common things in inheritance. If you have things that are very common in inheritance, like here you see commission employee, salaried employee, and hourly employee, it's much better to use abstract classes. But let us say employee and invoice are both payable. You need to pay both of them. You need to pay the invoice and you need to pay the employee. However, not really much common in between the two classes, except that they are both payable. In this case, we create an interface. I will do a simpler example with only two implementations of the interface. One of them will be invoice, the other one will be a speed ticket. Let me start with this example. As you see here, we have an interface called payable, payment amount or get payment amount. It returns double. And now we have two classes that implement the interface. One is called speed ticket, مخالفة سرعة. So you just need to know what is the street maximum speed and how much or what was the speed the car was actually driving there. And then you find how much to pay, المخالفة, the speed ticket. Then you have invoice, and invoice is, I believe we have seen this class before, item code, item description, and quantity, and what's the unit price. So the payment amount will be multiplication of quantity with unit price. So first, let's start with the interface. Here I'm creating a new interface, and the interface name is payable. And there is one method, which is public double get payment amount, and no implementation. Before I finish this, I need to say something. Interfaces can have methods that are implemented. يعني, not all the methods of the interface must be abstract. That is, with Java 8, you can provide partially implemented interfaces. We will cover this later. But now we have an interface called payable, and there is only one method inside it, which is get payment amount. Now, any implementation of the interface needs only to implement one method, which is get payment amount. Let me create the class invoice. This is an invoice class. Let us quickly create the public code, public private string code, and private integer QTY quantity, and private double unit price and a private string description. So these are the data members of the class. Let us generate getter and setters. Select all. Let us generate a constructor, fully parameterized. Generate constructor using field. I select all of them. And now there is one important thing, which is implements payable. The moment you say your class implements payable, the Java compiler will tell you you must implement all the methods of the interface payable, which is one method, get payment amount. So now I will just click on add unimplemented methods, and it has been added here, and as you see, override. So what is the payment amount? This dot get quantity times this dot get unit price. So my payment amount is this. So I have a class called invoice, and somehow it is also a payable. Why it's a payable? Because it implements all the methods of the payable interface. I will create another class. I'll call it speed ticket. Speed ticket. And here I will just provide private integer street max speed, السرعة تبعت الشارع. And here I will also see private integer car speed, سرعة السيارة. هاي كم بيحسبوا هاي. Let us just create setters and getters for the class, and then create a constructor using field. I'll provide both of them, and now I would say implements payable. And this moment again, Java compiler is going to ask me, I need to implement which method? The get payments amount. So let us make our own rules. If the difference in speed is less than 30 kilometers, then you pay 500 reals. If the difference is more than 30 but less than 50, you pay 1000 reals, and else you pay, for example, this is 1500. Okay, otherwise difference is greater than 50, then you're gonna pay, for example, 3000 reals. So this is the payment amount. Let's apply this rule. Let us say double difference is equal this dot get car speed minus this dot get street max speed. So now we know the difference. Now let's say if difference is less than 30, and here I would say return 500. Else, if difference is less than 50, return 1000. Else, return 3000. That's it. So we have implemented the get payment method for the speed ticket. We have implemented the get payment method for the invoice ticket. Now I can consider both invoice and speed tickets to be payables. This is some kind of polymorphism, but now it's an interface. However, the only thing that's common between them is the get payment amount method. Any class that implements the payable interface should have already implemented the get payment amount. Let's just make a quick tester here. Test me. Let's add a main method. And now I can create an array list of, or I can say payable here. Payable invoice 1 equals the new invoice. This is upcasting some kind of, okay. And this will be, the code is 1200. The quantity, I believe, is going to be 20. The unit price is this much. And the description is TV. Good. So we created one payable, which is an invoice. I can create another payable, which is speed ticket 1 equals new speed ticket. And here I can say the speed of the street was 80 and the driver was going 135 kilometers per hour. Now I also can, as you recall, I can say payable P. Oh, I don't have an array list. So now the only method that let us say here, I can call invoice 1 dot. The only method that I know is there is called get payment amount. All the other methods, as you see here, they are all inherited from the object grandparent. But only the get payment method is available. And I will do it also for the speed ticket. Here I will say speed ticket. So now I'm calling one method. Each has its own implementation in the implementations of the interfaces. Of course, you can create an array list of, let's see here, or an array. Here's an array list of payable also. Let us go, okay, pays, I'll call it, equals new array list of payable. And just initialize it, import the array list, and now do add the add st1 and do add pays also dot add. We have invoice 1. You can also loop as payables, يعني here for payable P in pays sys out. Of course, there is no toString here. There is no toString, so we will not see something useful. Good. Let us just try to go to the payable and see if we can, if we need to add another method, that's fine. If we don't need it, that's fine also. Now I will show you a third example here. I will create an employee class who is also payable. However, the employee has what? Private integer ID. We will do this quickly. Private string name. And this employee, I'll do it quick. Private double salary. We will go back to employee and rewrite the hierarchy. Setter and getter quickly. Generate setters and getter. No validation, no time for this. Create a constructor, fully parameterized. And now the moment you say implements payable, they will ask you to add that method, which is get payable. And here I will say this dot get salary. This is very simple. So all of them are payable from one side. Yani employee is an employee, but he is also what? Payable. Invoice is an invoice, but it's also what? Payable. Speed ticket is a speed ticket, but it's also what? Payable. They all have one method in common, which is get payment amount. Let me create now an employee. You can create it whichever you want here. I will create it as an employee, but once I add it to the array list, it will be a payable. a new employee, and here we have ID, and I think we have only name and salary. And let's say here 1, 2, 3, 4, 5, 6, and this is the salary. And I also want to add it to, since the employee is payable, it's addable also to the payable array list. Let us output here. So we get the get payment. We don't get the get payment for employee, but here let us say p.get payment since, okay, so now we get the get payment of all the three implementations of the payable interface. So let us consider, like in a real software development environment, you are implementing software part or module for the accounts payable, يعني المدفوعات, وفي accounts receivable, let us say. You don't care if this is an employee or a furniture or an invoice or a speed ticket. You only care about one thing, that these are what? Payable. Since all of them are payable and all of them implement the payable interface, you know there is a method called get payment amount. That's all you care about. In another example, maybe employee will be another thing. Maybe you will call employee from another side or use it as an employee directly without being a payable. But now you know employee is an employee and he is also what? A payable. يعني لو جيت أنا, if I come here to test me, and now EMB1, he is an employee. Look here, sysout EMB1 dot. You will find all the methods of the employee plus get employee or get payment amount. However, the employee inside the array list, as you have studied before, you will only find the things that are applied to the superclass or the interface, and here it's only get payment amount because you are dealing with them as payables. If you need to do some change of, if you need to do some changes to the salaries, for example, only for employees, you know now you need to do some kind of downcasting. Yani you can say if B instance of employee, and let us say you want to change the employee EMB, you need to do casting and downcasting. Temp is equal to employee now of P, and this is it. Now temp dot, you will see all the methods of employee class. Yani for example here I can say set salary 25,000, 250,000, and I will output this at the end to show you that I changed it only to employees because I did also downcasting. This is the payment of the employee. Interfaces are best with common functionality. In this example, invoice has not really much in common with speed ticket and almost nothing with employee. The only thing that they share is they are all payables, and there is one method or two methods. That's fine. Then you can use an interface. However, if there is a lot of commonalities and a lot of shared data members between the hierarchy of the classes, it's much better to use abstract classes, and you provide all the common features in the super abstract class, and only the changes in behavior you make abstract methods and allow subclasses to add their own data members. We will now go to the second part of this example. In the second part here, we will do another thing. We will make the employee abstract class because I have three types of employee. And I have salary employee, I have hourly employee, and commission employee. This class diagram, you already have seen it before. Look here, the employee is abstract. How do you know the employee is abstract? See, the class name is italics and the word A. abstract class, it's like an interface. However, abstract class can implement interface. However, it is optional to implement all the methods of the interface, as I will show you now. Now, I will delete this employee class. I will go also to test me here and remove the code. And I need you to pay attention to, actually there are so many details here. Now, my class hierarchy says employees need to be subclasses of the superclass employee. All employees have common things, so it's not worth it to make things like each class is directly implements the interface. So see now what I'm gonna do. I'm gonna create a new class, but this class now, this time is gonna be abstract. Abstract. Again, the class is abstract. So what do employees have in common? I put it here. I say private integer ID. I say it private string name. String name. And I already have explained higher date or local date. So here I can say private local date, and I would say higher date. Of course, you need to import higher local date from the time package. So far, this is an abstract class. I will make some methods here, source, generate, setters, and getters. I will select all of them. So far, so good. Now, the employee, first thing, the employee implements payable. Okay. Look here, they did not ask me to implement the get payment amount of the payable. Why? Because employee is not a concrete class, it's just an abstract class. يعني you cannot create an employee. طيب, in this case, any subclass of employee must implement the get payable or get payment amount. In this case, if the superclass, which is abstract, does not implement the get payment amount, no problem, this can work. However, any subclass of employee should implement the get payment amount. In the other hand, if the employee decides to implement it, خلينا نقول المثال اللي عنا إنه ما في مشكلة if to implement it here. In this case, the subclasses do not need to implement the method. So one level in the hierarchy must implement the get payment. If the abstract class do not do it, that's fine. However, the subclasses do not have any other choice. They must implement it. هلا كيف هالحكي يعني? Let us see this now. I will create another class. I'll call it salary employee, and I believe you know this salary employee. Now, this salary employee is not an abstract class. However, it extends. What is the, before we extend, what's the new thing? Only salary here. Private double salary, as you see here. Private double salary. The moment you say extends employee, actually, they will tell you you need to implement all the unimplemented methods. But where are the unimplemented methods? They are not in the employee class, by the way. They are in the interface that the employee abstract class implementing. So now if you click add implement, you will see that get payment amount is implemented from the payable interface. So here, since this is abstract, it doesn't have to, but any subclass of it must do it. So now let us see now. I'll go to employee back here. Let me just create for the employee. Let me just create here, generate constructor using field. Okay, good. Let me create for the employee, I will create a toString. Good. And here I will just say here, let us say this dot get what? Get class, get simple class name, very useful method, plus, okay, plus, let me say new line, or no need for new line. I will just say ID, and plus ID, close the ID here, and then name, okay, hire date, I will call it date hired, okay, and finally, actually, I don't have anything to do, but I can still add the payment amount here. Let us see if this is gonna work. So here I can say plus, new line, payment, amount, and let us see, plus this dot what? Do you see get payment amount? It is not implemented here, but definitely will be implemented in the subclasses. So now I have the employee. I created a constructor, toString, and everything. Let me go to salary employee. There is another problem. Because the salary employee extends employee, I need to call the constructor of the superclass. That's fine. So here I prefer to use Eclipse here. So now this is our employee. This is our employee. The new thing is only the salary. Let me just make sure here this is overridden. And I think I need to also make set salary and get salary methods here. So now I don't need to do anything except what? The get payment amount. So the get payment amount for the salary employee is going to be this get salary of that set. I will quickly go and do new class. And I will call it hourly employee. Definitely you have seen this example in many ways. Now I'll say private integer hours and private double rate. This employee has no salary, only number of hours. And let me just quickly do setters and getters. Done. The moment I say extends employee, they will ask me to do many things, and one of them is the constructor. Let me just go with the constructor. Good. And I need to implement the get payment amount, which was not implemented in the abstract class employee. So all the subclasses must implement it, no other choices. Now I do this. So get payment amount here will be this dot get rate multiplied by this dot get hours, and this one will return the payment amount. One third class here to make the example complete. I'll make it commission employee, where the commission employee has a percentage of sales, so private integer total sales or double, that does not make a difference at this moment. And here private integer percent, how much he gets. And quickly do setters and getter for the employee. Okay, what else I need to do? I need to say extends employee before I create the constructor. This way Eclipse is going to help me. Okay, and now when I say, so the superclass is employee, I have two other data members. And one more thing I need to do, I need to implement the method get payment, which was inherited from. So this one will be get total sales multiplied percent. Here percent needs to be double, and actually here double, and of course here is gonna be double. Hopefully no code errors. Multiplied here by this dot get percent. Where is percent here? That's it. So as you see, we have 5 different implementations of the get payment amount. All of them inherited from payable. The employee is an abstract class. You don't have to implement the classes of the interface. If you do, the subclasses do not have to. If the subclasses still need to make changes, they can override it, but it's optional. So now I'll go to the test me here. and I will create all employees first. Here I can also deal with employees as, let me say, payable here. Okay, salary employee 1 equals, payable must be capital P here. Okay, equals a new salary employee, and it's a payable, by the way. So let us say Steve Jobs, and the salary is 1, 2, 3, whatever salary here. Now this is a subclass of, hire date. Okay, hire date, let us say, I'll just put hire date quickly. Local date, as we have shown you how to use this in a separate local date. I'll call it hire date equals, and just import this now. Import it from Java time, a new local date, and I can say of 2020, and here it will be 1010. That's it. This is a date. So now I will call this hire date. All employees have date, as you see. And let's see here, change it to local date. Okay. Okay, the constructor, it seems, okay, local date dot off here. Okay. Let's see this. Okay, let me see that here. Here, local date of. Okay, what's missing here? I don't see anything missing. Local date of. Okay, it's gonna be a local date. Maybe I am, let me just make sure here, local date. Okay, of, let me see this, dot of integer year. Oh, I'll select this one. Integer year 2020, and here 10 and 10, and hopefully this is a correct. I don't really see where's the problem. Okay, change local date. طيب, I did change it, but what's the problem? The constructor is not available. I just created one here, and I will just make sure I cover this later. I don't have time to solve these problems at this moment, So, wallahi, I really don't see the difference, by the way. So I'll just call hire date, because I'm really covering different topic. I hate to, okay, local date. So now we have the hire date, and I will create another type of employee. I will say here, hourly employee, and HE1. I intentionally decided to create them in a totally different ways. A new hourly employee, and here the hourly employee is going to be the same thing. He's going to have ID, and name is Bill Gates. We will assume they were both hired in the same date, and this guy, he worked 30 hours and he is paid 45.5 per hour. So let me add these two things to the payables. So array list payable, and I will add the two new payable to the interface array list, and here is HE1, and we will notice a difference in the output, because the employees, as you see here, they all have a toString method. So let's see the output. Okay, here we say pay. Okay, hourly employee this much, and payment amount, of course, implemented in a different way. Salary employee that much. Now, for hourly employees, you can work with them as they are all employees. يعني you don't have to always work with them as payables, but they are. يعني here test 2, okay, I will create a sample one. Here, for example, I can create an array list of employee, which is a super class, and now use the concepts of polymorphism that you have learned before. Emps equals new array list of employee, So now you have an array of employee. Whatever an employee is an employee. If you want to deal with him as a payable, that's fine. Tamam. You need to do downcasting, upcasting, but this will help you a lot. So let me just go to the other side here. I will just do what here? I will get the two employees and payable. However, here, maybe since I am creating an array list of employee, let us see if they're going to accept SE1. SE1 was declared as payable. Let us see now. Emps, which is an array list of employee, add. Sorry, let's just add. Click add here. Dot add and SE1. Let us see what happens here. SE1 will not accept it because SE1 has been what? Declared as a payable. But if it was an array list of payables, yeah, we know this is a payable. But now you're creating an array list of superclass employee. So now you just can say here, salary employee or even employee or anything that is, every salary employee is an employee. Every hourly employee is an employee. Every commission employee is an employee. Now let's look at our interface and abstract classes here. So we have an interface called payable. It has one method. We agreed that speed ticket and invoice and employees are all payable. So we can make them classes of that interface. They just need to implement one method, which is get payment amount. However, we said salary employee, hourly employee, commission employee, they have a lot of list income, a lot of things are in common. It's not worth it to create separate class from scratch for each of them. So what we decided here, we said we're going to create an abstract class employee. We put all the common things in it, like ID, name, hire date, and many other things. We just did not want to make the class complicated. And then only the difference in behavior will be in the subclasses, salary employee, hourly employee, and commission employee. Since employee here is an abstract class, you don't have to implement the get payment amount in it. However, if it's optional, you still can implement it. But in our example, there was no need to do so. One final comment, I'll go back to the payable interface. This is our payable interface. We used, when we started working with Java, late 90s, early 2000, all the methods of interface must have been what? Abstract. However, later they added another way. They call it default. Here, for example, I'll say default double anything, get me. And this one returns what? Returns 0. So this is a method in the interface and returns what? Returns 0. So now what's the difference? Exactly like abstract classes. Not all methods of the abstract classes must be abstract. So the subclasses need only to implement what the abstract classes, and it's optional to override the implemented methods. The same thing here with interfaces. If you have methods in the interface that you don't think you need to implement in the subclasses, just make the method default. Default means no need to implement this method. Yani if I go to employee, no need. If I go to invoice, the method is available to invoice because it's in what? In the payable interface. All classes who implement payable, they have get me method. Of course, get me method can be overridden, but no need to implement it because it's implemented. How we know it's implemented in the interface? Just add what? Default and provide your own implementation. So not all methods of the interface must be abstract. You can use default. One final comment, use interfaces when you have only common behavior like payable, for example, in this example. However, when you have a lot of common in the class hierarchy, use abstract classes. Can I use both? I just showed you an example where employee was an abstract class, but employee still implements payable. So employees were employees and payables It depends where you want to use them, and you can look at them from that angle. Tuta tuta.